So if all of you were to open to page 33, that would be really, really good. Yo. Yeah, they're right there. Why didn't you get one yesterday? Yes, you were. Yes, you were. Really? Really? Okay, I believe you. There's a green book. Open to page 33. So surface area is outside only and only has two dimensions. It's only got a length and a width. Now, the term length and width, once again, doesn't mean anything. It's just, they've been named length and width because they go in two different directions. Now, you've been taught all the way along that length is the longer side, right? That's only so you can differentiate between the two. Does everybody understand? It does not matter which is which, because multiplication is what we call commutative, which means you can multiply in any order and it still works. So surface area is outside only and only has two dimensions because we only care about the amount of space visible on the outside. Volume is all the space. So therefore, it is 3D. If I hold up this piece of paper, you are all aware that this piece of paper takes up a certain amount of space in the universe, yes? It takes up 8.5 inches this way, 11 inches this way, and almost nothing up and down, yes? If I put it down on the desk and I trace around the outside, I make a border, the amount of space covered on the desk is surface area because it's got no thickness. Does everybody understand that? Right? And this piece of paper, while it does have a thickness, it is so small that we wouldn't even really measure it, would we? Everybody's cool with that? Okay. But if I take this shape, which is essentially two dimensions, right? And I stack it up 250 times, what do I get? I get a prism, right? All a prism is a starting shape, which we call the base, even if it's not on the bottom, and then it's repeated, right? Repeat this 250 times, I have a prism. Is everybody with me? Now, how big did I say this piece of paper was? 8.5 by 11, right? So if I take that 8.5 by 11 and I repeat it, I must get the 8.5 by 11 multiplied by how many times I repeat it, correct?
Yes.
So that is what the volume always is. The area of the base times the height in prisms and pyramids. Now there's a problem with this. When I say area of the base, do I mean the bottom? No. The area of the base is the two-dimensional area of the shape that repeats. So, it could be a triangle repeated backwards to make a prism. Everybody understand? It could be a circle repeated upwards to make a cylinder. Does everybody understand? It could be a rectangle repeated downwards to make a rectangular prism. Does everybody get it? Whatever shape I start with is my base. It is not the bottom. Everybody cool? And the reason I am stressing this is because of this. If I draw this cylinder, all of you have no problem saying that's the base. And all of you have no problem saying that's the height. But as soon as I turn the cylinder on its side, everyone's like, what? This is the height. And that's wrong. The base is the shape that repeats. Everybody cool? Which means that the height is not up and down. The height is the direction of repetition. So whatever direction that shape goes, that's your height. Doesn't matter if it's lying down, doesn't matter if it's turned on an angle, doesn't matter. Whatever direction it goes, it's the height. Is everybody cool? Always. Now, each of these bases have a different formula, don't they? A triangle base is base times height divided by 2. There's those words again, base and height. A circle is pi r squared for the area of the base. This guy is length times width for the area of the base. So the area of the base changes, but it is always multiplied by the height. Everybody cool? That is for prisms. Pyramids are special. What shape is this? Cylinder. Is it a prism? Yeah, because it's a circle that repeats separated by a rectangle, right? But if I turn it to this, now what do I have? A cone. Now the problem with a cone is it the same size as a cylinder? Or is there empty space in there? There's empty space in there, yes? So a pyramid starts the same as a prism, doesn't it? Starts at the same circle, or starts at the same rectangle, or starts at the same square, yes? How does it change? It comes up to a point, yes? So we still have an area of a base, because the base hasn't changed. It's still area of base, and it still has a height. But you can see in that little demo I just did that there is empty space there, yes? It's not as big. So we divide it by 3. And that's from experimentation. Back in the day, the guys, and they were all men, I'm not being sexist, but back in the day, everybody that did math was a man. The guys that made this stuff up figured it out from practice. That's how the formulas came about. So you'll also see this written as 1/3 area of base times the height. 1/3 times that is the same as divide by 3. And all that's on your data booklet, right? So now we're going to go back. Remember how we split the page in half? We're going to go back. We're going to do the volume of all of those previous things. Okay? So go back to page 27, which is where it starts. And we've got our cereal box right here. Now, rectangles are the easiest ones because they have, they've got a set formula. It's easy. It's length times width times height, always. But I want to stress a point here because I want you to get used to this. Area of base times the height. So the area of the base is the repeated shape. What is the repeated shape? It's a rectangle. Does it matter which rectangle we start with? No. I could start with this rectangle as the base, couldn't I? I'm actually going to use a highlighter to do that. Sorry. There's my base. So the area of that is LW, right? So all I got to do, I've already drawn it this way. I've said that's 24 and that's 40. So there's my area of the base. What is the height? That's the direction that it repeats. Where does that rectangle go? It goes back this way, yes? So that makes my height 8. LWH is 40, 24, 8. And then you do the math. Now, I know 7,680 centimeters cubed. Why cubed? 3 dimensions. I know for a fact that the first time you were taught volume, you were taught LWH. I know this because my kid just finished grade 6. She just did volume. So you were all taught LWH. But she was not taught area of base times the height. She was just taught LWH, which is wonderful if every single shape in the universe was a rectangular prism. Are they? No. So learning just LWH works in one scenario. Area of base times the height works in every scenario. Does everybody understand? And I don't understand why in grade 6 they stopped here instead of starting here. But I'm not a grade 6 teacher, so I don't know. Everybody cool? All right, let's go to the next one. It's a pyramid. So, I know that volume of a pyramid, and I look on my sheet, it is a prism it's related to prisms, so it's still going to be area of base times the height, but now I got to divide by 3. The area of the base is the shape I started from. In this case, it was the square pyramid. So what was it? I got it drawn right here. How do I find the area of a square? 32 times 32. Or 32 squared. Times the height. What was the height? 65. Now, I'm going to put a warning here. Volume needs height. And highlight height. Over here, remember, surface area needs slant height. And I'm going to highlight that too. Know the difference. Height goes straight up the middle, slant height goes up the side. What finds those two? If I know one of them, how do I find the other? Pythagoras finds these if needed. Come back to my last step. My last step is divide by 3. Now again, this needs practice on your calculator because some of you will punch this in poorly. Okay? Most calculators are good at BEDMAS. You can just go 32 times 65 divided by 3, and it will work. But it might not, so let's check. Who has a number for me? .67. It's fine. Did I not finish going over page 31? I didn't, did I? Right. Okay. So we'll finish these 5, then I'll go over 30, 31, then I'll let you work. Sorry about that, ladies and gentlemen. And this was, of course, feet cubed. Okay. Is a cone a prism or a pyramid? Pyramid, because it goes to a point. So I start with a prism, area of the base, times the height, and I have to divide by 3. Now I drew this one upside down. Why? To remind you that height is not up and down. Okay? So the area of the base is a circle, which is pi r squared. The height is the direction that circle goes. And then I divide it by 3. Pi. What was my radius here? 15 squared times 22 divided by 3. Now, we're in the 10th grade, so are we going to do anything with pi? No. So it's 225 pi times 22 divided by 3. $4,950 pi divided by 3. Do that division and I get 1650 pi. Now, is that an acceptable answer? Am I happy with that? You finish this whole question, you leave it like that. Do you get the A? Yes. What if you're doing multiple choice and you see nothing with a pi there? Then what do you have to remember to do? Do the multiplication. Everybody with me? So remember, if it's a multiple choice test or if it's another teacher or whatever, remember, you might need to do this. Is everybody cool? And lastly, we had a cylinder. Is a cylinder a prism or a pyramid? It's a prism because it doesn't come to a point. So since it's a prism, it's always area of base times the height. The base here is what? A circle. No matter how I spin it, what's the base? Still a circle. Why? Because it's the circle that repeats. There's more than one circle. If I cut that cylinder up, I get a bunch of little circles. So it is pi r squared h. Pi, our r was 5 squared, and our h was 20. 5 squared is 25. Pi times 20 is 500 pi. Am I happy with that? Yes. Depending on the test, again, you might have to hit 500 times the pi button equals. Remember, you have to know how your machine works. You might not need to push times. You might, like on my calculator, be able to go 500 pi equals. You might be able to do that. Depends on the calculator. Who knows how to work your calculator? You do. I do not until I see it. Everybody understand? You got to figure out how your machine works. Everyone's good? Sweet. Okay, now let us go to this page and finish this page off. I apologize, ladies and gentlemen. My brain was in my bum. So G. This one is fun because a lot of people do this right, but they do it a really, really long way. I'm going to get out a highlighter because it's kind of like painting it, right? If I painted this, everything blue is surface area, yes? Does everyone agree? And everything I have painted blue, if I added it all up and doubled it, I'd have the surface area, wouldn't I? Right? Because there's a back and a bottom. Everybody cool? So if I did put a line right there and I did 1, 2, 3, 4, 5, 6 rectangles, added them up and multiplied by 2, I'd have the answer, wouldn't I? Is that okay to do? Sure, it's going to work, isn't it? But it's going to take a long time, right? I want to show you guys a trick that is very helpful for these weird shapes. Watch what I'm about to do. What do I have there now? I have a rectangular prism, don't I? Which is 2 WH plus WL plus LH, correct? And isn't that the exact same shape as that? Except this little rectangle is missing, isn't it? Right? And how many of those little rectangles are missing? There's one there and one at the front, right? Times 2. So if I did this minus the pink rectangle, minus 2 times the pink rectangle, would I have the right answer? In way shorter time, yes? Is it any more right? Is it more right? No. But it's significantly faster. Does everybody understand? Picking up what I'm putting down, read my mail, mow my lawn? So, if I do it this way, I can do it in one step, can't I? W and H. Who decides where W and H are? You do. I'm going to write W and H on here, WH and L on here. They might not be the same as yours. Will it matter? Why not? Because multiplies multiply. If I make this W and I make 22L, What's the H? 4. So there's my H. So WH is 6 times 4. I'm just going to do that in my head, right? 6 and 4. 24 plus WL, 6 and 22. Yeah? Which is 6 times 20 is 120 and 6, 132. Plus LH, 88. Everyone agree? 622 and 422. And what's this guy? Minus 2. What's this guy? How far is this? 2. And how far is this? 11. 11 times 2, which is 22. And now I can just do the math. 24, 132, and 88 is 112. 244 times 2 is 488 minus 2 times 22 is 44. 444. Is everybody okay? Now, could I, again, I remind you, have done this and just added everything up? I could have done this guy, which would have been 11 by 4. This guy, which would have been 11 by 6. This guy, which would have been 2 by 6. This guy, which would have been 2 by 6. This guy, which would have been 11 by 6. This guy, which would have been 11 by 2. Added it all up and multiplied by 2. It's just a little more work. Everybody cool? All right. Now, I want to show you something with this particular question that will help, that also applies to volume. I'm going to erase this for a sec. If I wanted the volume of this, is this a prism or is it a pyramid? Prism. It's a prism because this shape repeats, doesn't it? Right? Because that's at the front and that's at the back. So isn't the volume of a prism area of base times the height? And isn't the area of base the repeating shape? Repeated shape. And isn't the height the direction it repeats? So doesn't that mean this yellow here is a base? And this, that's a base. And this is a height? Does everybody see how that works? I've been teaching math 20 years. I used to not tell kids this. Do this demo. I used to say, it's always the area of the base times the height. And the height is the direction that it repeats. And then I give the kids this question, and they try to do the volume. And they say, okay. And they cut it in half, and they do this volume, volume 1, volume 2, and they add them together. Is that okay? It is. Except sometimes there's weird shapes that you can't just cut in half. So this move, where you make this the base, that will help you find the volume. Because no matter what that is, it will work. Picking up what I'm putting down? Read my mail, mow my lawn? Okay. Surface area of a cylinder. We remember that it is 2 pi r squared. Why? Because there's 2 circles. Plus 2 pi r h. 2 pi r is the circumference, which equals the length of the rectangle. H is the width of the rectangle. So then all we do is fill it in. 2 pi 3 squared plus 2 pi 3 times 8. 3 squared is 9. 9 times 2 is 18 pi plus 3 times 8 is 24 times 2 is 48 pi. And the answer is 66 pi. Can I leave it like that? Am I happy with that? Are you happy with that? What is the only time you would need to not be happy with that? When you need the actual number, right? If you were to go to Home Depot and say, I gotta paint this silo that I have on my farm, and it's 66 pi meters squared. Or meters, squared, surface area. That's not useful, is it? Right? You can't go into Home Depot and say, he says, well, how much square feet do you have to cover? Square meters do you have to cover? You say 66 pi. That's no good, right? So in real life, we need a number there. But in math class, we're perfectly happy with 66 pi because it's tidier. Everybody good? Sweet. Jim wants to paint his living room. This question is going to have been, you're going to have done the math correctly, but you're going to have gotten the wrong answer, most of you. And it's going to trick you. And you're going to be like, damn, of course, as soon as you see it. But first, let's talk about it. In a room, what do you paint? The walls? Sometimes the ceiling. What do you almost never paint? Why? Because it's your floor. It's got wood on it or carpet or something. You don't paint the floor. Everybody with me? All right. You don't always paint the ceiling, but sometimes you do. So the first thing is, some of you are going to have painted the ceiling, some of you are not. That's okay, I don't care, as long as you told me you were painting the ceiling, yes? So our room has 4 walls and a ceiling, yes? Our room looks like this. Everyone agree? How tall is our room? 3 meters, so this is 3. And the room is 4.1 by 5.3, correct? Everyone agree? And I'm going to paint, it's a rectangular prism, yes? So I would need to do 2 WH, HL, LW. Except I'm not going to paint minus the floor. Agreed? Now, here we need to stop, and here's why. Read the question. The paint is sold by square feet. The room is measured in meters. Everybody with me? So, if I do this work right now, I am going to get an area in something meters squared, aren't I? And that's easy. We just punch in the numbers and we get it, right? Let's do that. So, WH 5.3 times 4.1, 4.1 times 3, and 3 times 5.3. And then that whole answer, I got to multiply by 2. So I'm going to do that. I'm going to do it on my calculator that you guys can see. 2, bracket, 5.3. Oops, I needed 2 brackets there. 5.3 times 4.1, close brackets, plus 4.1 times, I forgot the brackets again. Bracket, 4.1 times 3, close brackets, plus bracket, 5.3 times 3, close brackets. All of that minus the floor, which is 5.3 times 4.1. Does everyone agree? You all watched it go in there, you trust me, right? So our room is 56.4 meters squared. If I'm painting the ceiling. If I don't paint the ceiling, it's going to be a little less than that. Everybody agree? If I don't paint the ceiling, it's going to be 56.4 minus... It's going to be 34.7. That's no ceiling. How many people did this first, if they did this at all? How many people used the meters? Okay. Which means now you have to convert to feet, right?
Convert the square feet of paint to...
You have to convert the square meters to square feet, right?
Or the square feet of paint coverage.
Yeah. Or you, at some point you've got to convert square feet to square meters. That's what I'm trying to say, right? This is where you're going to make your mistake. If you made a mistake. Not everybody will have. I'm going to go to my extra page here that I always do. That line is 1 foot. How long is that in meters? If you look on your sheet, you will see it is 0.3048 meters. Agreed? Everyone agree? But I'm not converting one line, am I? What am I converting? I'm converting a square, aren't I? So that is 1 foot, yes? So that makes this square 1 foot by 1 foot, 1 foot square, yes? How far is this in meters? 0.3048. What do I have to do with 0.3048 and 0.3048? I have to multiply them together. So this is 0.9093. So 1 foot equals 0.3048 meters. But 1 foot squared equals 0.093 meters squared. It's a different conversion factor. Does everybody understand that? Oh, the screen went blank. So no, you don't understand it. Let me get it back. There we go. Does everybody get this? You have to convert twice because you're converting for 2 dimensions. What if I was converting feet cubed to meters cubed? Then I have to convert how many times? 3 times. I have to do 0.3048, 0.3048, 0.3048. Does everybody understand that? So we come back to here. And if I want to convert this, I have to go 0.3048 squared. Everybody with me? That is one option. Your other option is to convert all of these to feet now. And since that's only 1 dimension, how many times do I have to convert? Just once for each, right? So this would be 3 divided by 0.3048, 4.1 divided by 0.3048, and 5.3 divided by 0.3048. And that would give me feet. Once I had my feet, I could take these numbers and put them in down here. Does everyone understand? Now, I don't like to do this because this is more work. But this requires me to understand more math. Does everybody see the difference? So I'm going to continue to work with this one. I'm going to agree with Erlen that I'm painting the ceiling. So that's how much I got, right? Meters squared. And I got to convert that. What do I want? I want feet squared over meters squared, right? Because I want feet. 1 foot, yeah, is 0.093 meters. The 1 is always crossed out, so I got 56.4 divided by 0.093. And that gets me my answer. On. He wants it to turn on. Turn on. $606.45 feet squared. 1 gallon of paint covers 300 square feet. How many gallons of paint do I need? What do I do with that to find out the answer? Divide it by what? 300. And I get 2.02. Yeah? Everyone agree? That answers the first question. Nearest tenth, 2.0. But I can only buy paint in gallons. I can't go to the hardware store and say, hey man, I need like 3 tablespoons of paint. So I really got to buy how many gallons of paint? 3 gallons. If I'm painting the ceiling. Everybody understand? The math is the same if I'm painting not the ceiling. I just do the same conversion. I'm just going to need less paint.
Good morning. Please excuse this interruption. Staff, if we could have you take attendance in my and please post, you should be able to do that now. Thank you.
And that's all the right answers there. Any questions? All right. You have until the 9:15, and I'll probably give you some time afterwards to work on page 35, 36, 37, 38. I will give you till your break, and I will give you 20 minutes after your break. At 9:45, we will be going over this, and after we have gone over it, you will write your quiz on surface area and volume. Everybody good? Go. I've got to take attendance. Spheres don't take long. It's just a formula. Skip number 1. We'll come back to it later. Go to number 2. So I got a box. That's 3 by 3 by 9, yes? And that box holds 3 golf balls, which I can only draw as circles. Can't draw spheres. Right? I want to find the empty space in the box, which sounds like a stupid math question, doesn't it? Right? Stupid math class question. But it really isn't, because somebody has to decide how big to make a box. There's actually people that make their living doing stuff like this. So, I need all of this empty space, correct? What math would that be? What finds the difference in something? Subtraction. So really what I have here is the volume of a prism minus the volume of how many spheres? Oops, forgot the P. The volume of 3 spheres, correct? Okay, so let's fill this in. What's the volume of a prism? We know that it's LWH minus 3, the volume of a sphere. Now, the reason I skipped number 1 and all that stuff right there is because it's summer school and we don't really have time to explain it. A sphere isn't a repeated shape, is it? It starts from a circle in the middle, and then it goes up and shrinks, kind of like a pyramid, but it also goes down and shrinks, kind of like a pyramid. Or it spins infinitely in every direction. Yes? So it's hard, you can't build a sphere like we built the pyramid and the prisms. So spheres, you just got to know the formula. And you don't even have to know it. You just got to write it down or read it. But there's a problem with it. On your worksheet or on your data booklet, it looks like this: 4/3 pi r cubed. I don't like that because you guys don't like fractions. So the way I like to write it is this: 4 pi r cubed. Put that in brackets. And then divide the whole thing by 3. Everybody with me? So when you punch that into your calculator, you use the brackets. Because if you don't, your calculator does BEDMAS. So 3, and the spheres are 4 pi r cubed divided by 3. Now, when you write it out, it's super easy, correct? Because what happens to that 3 and that 3? I got a times 3 and then a divide by 3. So what happens to them? They're gone. So really, it's just LWH minus 4 pi r cubed. Do I know my LWH? What are they? 3 times 3 times 9 minus 4 pi. What's my r? This is tricky. It's 1.5. 3 times 3 is 9. 9 times 9 is 81 minus 1.5 cubed. Go to my calculator. I know the answer, but why is it 1.5? Okay. The sphere takes up the whole box, right? A radius is half a circle, yeah? A sphere is just an infinite amount of circles. So if the sphere is 3 wide across the middle, then the radius must be 1.5, because all those infinite circles share that radius. Got it? Turn on. Turn on. I know you can do it. There we go. Cubed. 3.375 times 4 equals 13.5 pi. Now, this is where it gets a little weird. Myers has said he wants you to leave it like this, yes? Right? But does that answer help the people that are going to make this box for you? No. So in this situation, what would I want to do? I want an actual number, right? I would do 18 minus 13.5 times pi. 18. 81. Okay? So I would actually punch that into my machine, which is 81 minus 13.5 pi. 38.6. Everybody cool? Hey, Mr. Radnai. Centimeters cubed. Yeah, I stole James's Penworks. But I went over to Start yesterday, and Leo says, it works. Leo, it doesn't work. It works. I tested it. Leo, it doesn't work.
It's like my machine.
Yeah. So
turn it on, it has a blue screen, but no logging.
Yeah.
It
so
works.
I told him, I said, I did the drivers. I did this. So he said, he starts doing all this stuff. It's like, I did that. And then finally we get to the end, and he's like, it doesn't work. I know, Leo.
But why would the average teacher really should have to do that?
No. 90% of the people
would
in this, 90% of the people in this building
Why?
don't even know what a driver
And
is.
that's fine,
Yep.
right? Because that's not their job.
No.
You know what? Turn it off. It doesn't work. Get rid of it.
Yep. They are getting rid of him. Carmen, the other guy over there,
Yeah.
he hates
Right.
him.
Yeah.
So he's got a Dell that flips over like our old Lenovo's. So he says that's what he's getting us next.
Until then,
Till then, we muddle through with these. I have to send mine for re-imaging.
Yeah. Oh, you won't be the only one.
Oh, I know. All right. So is everybody cool? I did 81 minus, well, here, I'll do it in step by step. 13.5 pi is 42.4, right? So then I did 81 minus that. I did, but I did it all in one step right there. 81 minus 13.5 pi. My calculator might be different than yours. Now, there's a whole bunch of white space at the bottom of this page for a reason. Surface area of a sphere equals 4 pi r squared. You already know how to do that, right? You know what r is, you know what pi is, you're good. Volume of a sphere equals 4 pi r cubed over 3. Now, sometimes we mess with spheres. For example, what if I want the surface area of a hemisphere? What's a hemisphere? That's half a sphere, right? Everyone agree? Okay. So a hemisphere is half a sphere. Yes? So doesn't it make sense that the surface area of a half a sphere would be 4 pi r squared divided by 2? Right? Which gets me 2 pi r squared, correct? Except look. If I cut a solid sphere in half, what did I make right here? A circle, right? Is that surface area? So I have to add another circle. What's the area of a circle? Pi r squared. So I have 2 pi r squareds plus 1 more pi r squared, which is what? 3 pi r squared. That is the SA of a hemisphere if it's solid. Now this gets tricky. What if it's hollow? Then what's the surface area? The same as a whole sphere, right? Because the inside is the other half of the outside. Everybody with me? Okay. Now let's talk about volume of a hemisphere. Well, a hemisphere is half a sphere, yes? So it must be 4 pi r cubed divided by 3 divided by 2, correct? Everyone agree? That's kind of weird. So that is 4 pi r cubed divided by 3 times 1/2. Everybody cool? Because times by 1/2 same as divide by 2, right? So that is 4 pi r cubed over 6. Everybody still cool? And then, of course, what would you do with 2? I just gave it away. What would you do with 4 and 6? Because they're a fraction. What do? Simplify it to 2 pi r cubed over 3. That is the volume of a hemisphere. Now, you won't find those formulas on your sheet, will you? Because it depends on what you're doing with them, right? It's my gift to you. Everybody good? Now, because I forgot to do something and took up some more of your time, I'm going to bump everything back. You will write your quiz at 10 a.m. instead of 9:45. $10 a.m. for quiz. Your break is going to be in 10 minutes. So between now and 10 a.m., I want you to finish 36. Is it 36? Yeah, 35 to 38. As much as you can. We may have to come back and check on it. And I'd like to write the quiz at 10, but we're not locked into that. Cool? All right, are you allowed to move around and work with whoever you want? Yes. Remember, surface area and volume are different things. We're going to come back and do number 1 later. Do not do 2A on page 36. I want to work through that with you. You can try it if you want, but it will frustrate you.
Number 1. I want to
difference does it make? 1,000. Yes. Watch. We are on page 35. A square pyramid with a base of 6 and a slant height of 8. A square base, which means it's got 4 triangles coming off the side. I don't really care if you didn't draw that. The base is 6 by 6, because it's square, and the slant height is 8. 2bs plus b squared. 2 times b, 6, times the slant height, 8, plus b, 6, squared. 2 times 48 plus 36, 96 plus 36, 132 meters squared. You're just following the formula. A cone. Radius is 15. Radius goes right there. 15. Height, 25. Cones are, SA is pi r squared plus pi r slant. Right off of your sheet. Do you have a slant? No. Have I spent time discussing how to find a slant? Yes, I have. As a matter of fact, it is written right here. Pythagoras finds what is needed. So, this red triangle here is 25, 15. I need this, which is the square root of 15 squared plus 25 squared, which works out to 29.2, I believe. 29.15.
Yeah.
29.2. So that is my slant. Then all I do, once again, is fill in the formula. Pi times 15 squared plus pi times 15 times 29.2, which equals 225 pi plus 15 times 29.2, 438 pi, which gives me 663 pi, which is perfectly acceptable. Some of you cannot accept that. You will need a number, which is 2082.9. Anything around that would be acceptable. Pardon? Everybody good? A sphere, the surface area of a sphere. It's right on your sheet. Surface area of a sphere is 4 pi r squared. 4 pi times 25 squared. 4 pi times 625. 4 times 600 is 2400. 4 times 5, 25. 2500 pi. If that's not good enough for you, 7,853.98, so 7,854 meters squared. Meters squared. I said not to do 2A. We might as well talk about it right now. A triangular pyramid with a base of 13. If it's a triangular pyramid, that means it starts on the bottom with a triangle. Yes? If the base is 13, that means all of these are 13, correct? Now, the volume of every pyramid is area of the base times the height divided by 3, correct? That's the base, yes? What shape is it? It's a triangle. The area of a triangle is base times height divided by 2. Do you have a base? Do you have a height? No, you do not. This is unknown. But 13, 6.5, and h, you can figure out h, can't you? Using Pythagoras. H equals the square root of 13 squared, plus or minus here, minus 6.5 squared. H is 11.3. So that is this H, which is right here. Okay, Jimmy, I am only finding the height of this triangle because I need to find the area of that triangle first. Okay? So now I know this triangle, and I will keep working in blue so it is not confusing. What's the base of this triangle? 13. What is the height of this triangle? 11.3. And then I divide that by 2. $73.45. This is the area of a triangle, which means it is also the area of the base. 73.45. Now, Jimmy, what's the height of our pyramid? 9. So then a 9 goes there, and then I divide the whole thing by 3. That's why that one's really hard. That's why I didn't want you to do it. In my regular class, when I have more time, we spend a lot of time discussing questions like this, right? We don't have that in summer school. That's why I just wanted you to see it. Everybody with me? Okay, now we'll get back into an easy one. A square pyramid with a base of 4 and a height of 15. I want the volume. Volume is always area of base times the height, and since it's a pyramid, it's divided by 3. The base is 4, so that must mean it's 4 times 4, because it's a square pyramid. Its height is 15, and all that is divided by 3. 4 times 4 is 16. 16 times 15 is 240 divided by 3. 240 divided by 3 is 80 meters cubed. Everyone should be feeling good because all you're doing is filling in formulas, except for that one that's really hard that I told you not to do. Volume of a sphere. Is there a formula for volume of a sphere?
Yes.
What is it? 4 pi r cubed divided by 3. 4 pi 18 cubed. Now, somebody I saw doing this did 18 squared. They did 324 here. It is cubed divided by 3. So 18 cubed, it's 4 pi times 5,832 over 3, which is 23,328 pi over 3. Then you divide that by that to get 7,776 pi. Of course, if you don't like that answer, it's 24,429. And finally, a cone with a radius and a height. Volume of a cone, since it's area of base times height divided by 3. Since the base is a circle, it's pi r squared times height divided by 3. Pi times 25 squared times 12 divided by 3. And then you could finish that off. I'll get it. Go Myers. Hey. I did. Sure. Am I posting in class today? Okay, I 100% did. I will do so again. Okay. So that is 625 times 12 is 7,500 pi divided by 3, which is 2,500 pi, which is 23,561.9. All of you should be good to there, because that's just filling in formulas. Carry on to this page. You.
Volume of the hemisphere is 2 pi r cubed divided by 3.
Yes. Okay, ladies and gentlemen, if you look on the board, you will see all the work, every single step you could possibly do, and it recorded. I didn't speak about it because you were working, but it's all right there on the recording from today. Please notice what I did first. Before I did any math, I looked and decided what was actually happening. When I cut that hole out of there, that made the top circle and the bottom circle disappear. So the prism lost those circles. But when I cut this, it gained the sides of the cylinder, which is why I added the sides of the cylinder. Then I just wrote out the formulas, a prism minus 2 circles plus the sides of the cylinder. Then I just filled in the formula. The difficult thing in this unit for math is not filling in a formula. All of you can do that. This is the hard part. This is what you need to practice. Does everybody understand? Is that enough explanation for you to see every single step? Zach?
Is there a reason that 9,400 plus 337.5 pi equals a number smaller than 9,000?
Oh man, what did I do there? You're right, 9,400 plus 337.5 pi. Yeah, whoo, thanks, Josh, or Zach. That is 10,000. Oh, I know what it was. That was the minus the 112 pi. I forgot to add that in. 10,000. Thanks. 60.3. Now, let's say that happens to you. You show me all this work and you forget to add that back in. Do I still give you a pretty darn good grade? Yeah, I do. Because this is hard to estimate, yeah? Now, Zach figured it out by saying, if I started with 9,400 and I added to it, how did I end up with less than 9,400? Right? That's the type of thing that you could possibly catch yourself on. Erlen.
How did 112.5 plus 450 come through?
It's negative 112.5 plus 450. Everybody cool? All right. Now, again, I ask, is that okay to see it all in one spot and hear the explanation? Because I'm going to do that same thing on number, whatever the next number is, while you people continue to work on it. Cool? Okay. And there is the second one. Surface area in red. Again, I remind you to decide what you are doing in words before you do it in math. You had the big cone, but you cut off the small cone. So you lost the sides of the small cone. But you gained the circle of the small cone. So that's why you add the small cone circle on there. But you needed two slant heights. You needed the big cone slant height with 9 and 12, and the little cone slant height with 3 and 4. And then volume is, of course, easy. It's just minus. Volume of the big cone minus the volume of the small cone, which I have right here. Yes, you. I have an answer, Loveline. Which one? B? Okay. Well, you're doing surface area, yeah? Okay. So that's the front of it, right? Which means that on the back of it, there's the same thing, yes?
Yeah.
And that is 6 and 8, correct? So that is 8 and 6, correct? So doesn't this cover the front and the back of the triangles? No, this whole thing that I made here, that's the front and the back, yes?
Yes.
So what is the area of that rectangle?
2 times
This is just a rectangle. It's the area. Length times width, which is 48, correct? So that covers the front and the back, yes? Now, they've already been covered, right?
Yeah.
Okay, so now I need, there's a rectangle on the back here, correct?
The same one?
No. This rectangle is on the left, right? This one back here, right? You can't see it, but you know it's 6 tall, and you know it's 7 that way, right?
Yep.
So how big is that one?
6 times 7.
Yeah. 42, right? And you know there's a bottom. How big's the bottom? 8, 5, 7. How big's that one? Just tell me what you would do if you had your calculator. Right, so it's 56. Okay? Now, the only thing left is this rectangle, which you know is 7. And you know this is 6. And this is 8. Well, doesn't that make a right angle triangle? Yeah. So 6 squared is 36. Plus 8 squared is 48.
And then you can find the
Yes.
answer for that.
Right? Or 8 squared is 64. 36 and 64 is 100. Square root of 100 is 10. This is 10 and 7, so what's that?
That.
10 times 7, so what's the area?
Yeah, when you multiply 10 by 7.
Which is 70. So now I know that rectangle, that rectangle, that rectangle, and that rectangle. What do I do with all those areas? That's it.
What if the teacher gives you find the volume?
Well, okay, yeah, you're right. There isn't, except to know this. That is what we have right now, correct?
Yeah.
Okay. What's that?
Square.
A prism, right? Well, if I cut it in half, then what do I have?
Rectangle with.
I have half a prism, right? So, since I have a length, 6, a width, 8, and a height of 7, if I filled in the rest of that prism, then I would have 7. And then I cut it in half. So what would you do with 6 times 8 times 7? This is length times width times height, right?
Yeah.
Which is 6 times 8 times 7, correct?
Yeah.
This is half of that. So what would you do with that number?
Multiply and then divide.
You would just, multiply these out and then divide by 2. Okay? Yeah. I know. 10:30. Break is at 10:40. I guess we're having our quiz after the break. Yeah. Kirit, you're going to be allowed to leave the class twice in a day. Once to get a drink, once to use the washroom. This is your second time. You sure? There's a break in 10 minutes. You can't wait? Okay. Mm-hmm.
Is the quiz multiple choice?
Mostly.
It's mostly multiple choice. I even went to blow my nose.
Okay.
It's also counted.
It's cool. There is the cylinder. Check your work over and make sure. Yo.
This equation, are you supposed to do it the top part all at once?
Yes.
Because my calculator doesn't seem to be able to.
Yeah, you got to do it all at once. So you're going to put brackets. You're going to follow me. Ready? Start right. Start typing. Bracket. 4 times pi button times 18. Now your exponent button. Yep, 3. Close brackets. Divided by 3.
Okay, so that's what you did?
Yep. Because if you don't put those brackets in, your calculator is going to do bed mass. Right? Because that is saying you want to divide that whole answer by 3. If you don't put in the brackets, your calculator doesn't know you want that whole number at the top. Yeah. Yeah. And there is the hemisphere. And there is the double. Now, listen please. The bell is going to ring in a minute and a half. You are taking your 15-minute break. When you get back, I will entertain questions for a maximum of 10 minutes before your quiz. You will then write your quiz. You will hand it in to me. I will mark it sometime today. Then we will move on to Unit 1's review. That is in your book. You will work on that for all of that block. Okay? Going once. The quiz does have those kind of stuffs. Because those kind of stuffs are math. And the quiz is on math. Just ask which one. I can go over it slower and I can go over it step by step, or I can draw one that's like it and you can try it. So one of those with the piece missing. All right? Easy to do. The middle has been cut out of this. I have made a tube or a pipe, which happens. You have to be able to, it's one of those things that happens in real life. Somebody's got to make pipe. So, if I wanted the surface area of the resulting structure, what would I have? Well, if the pipe wasn't cut out, I would have the surface area of the green cylinder, correct? Everyone agree? Okay. Now, if I cut the red cylinder out of it, that's a hole at the top and bottom, yes? What math is removing? So I would subtract 2 circles, because I'm using the red, right? But once I cut that hole, what did I make? What is all of this? It's the sides of a cylinder, right? That wasn't there before I drilled the hole, was it? So if it's new surface, what math is that? Add the sides of the red cylinder. That's why I write it out before I go to any formulas. Now it's super easy. I started with the green cylinder. The surface area of a cylinder is 2 pi r squared plus 2 pi r h. Get it straight from the formula sheet, yes? Then it says to subtract 2 circles. Okay, well, minus 2 circles are pi r squareds, yes? Then it said add the sides of a cylinder. Well, if I look at my data booklet, the formula for surface area of a cylinder is broken down, isn't it? Top, bottom, sides. So I have to add the sides, which is 2 pi r h. Right? Now all I do is I fill in the numbers. Let's give you some numbers. This is 20 centimeters tall. The green one is 5. And the red one is 2. Then all you do is fill it in. 2 pi, what's the green r? 5 squared plus 2 pi, what's the green r? 5, the green h? 20. Minus 2 pi, what's the red r? 2 squared plus 2 pi, what's the red r? What's the red h? Also 20. Then you just do math. 5 squared is 25 times 2 is 50 pi. Plus 5 times 20 is 100 times 2 is 200 pi. Minus 2 times 2 squared is 4 times 2 is 8 minus 8 pi. Plus 2 times 20 is 40 times 2 is 80 pi. Then you just add it all up. 250 plus 80 is 330 pi. Take away 8 pi, 322 pi. There's no tricks. There's nothing weird. You just have to think about what is actually happening. And I can't stress this enough. If you write it out in words, then you write it out in formulas, you cannot do it wrong, can you? It tells you what you need, and you can see from the drawing what those things are. When is it a problem? What are some things that you sometimes have to find? Do I always give you a radius? What do I sometimes give you? A diameter. So you might need to find r. which is the diameter divided by 2. Right? Sometimes you need to find slant. What's that? What do I use? Pythagoras. If I need the slant, is it Pythagoras addition or Pythagoras subtraction? It's the addition version. What if I have to find the height? Then it's still Pythagoras, but which is it? It's the subtraction version. Okay? Let's do another one. What if... Now, there was that silo question about volume, right? How much I can fill it up? Well, now I want to paint the silo. Is painting volume or surface area? Surface area. So a silo looks like this. There's a cylinder, and then there's a hemisphere on the top. And there's usually a door in it somewhere, blah, blah, blah. Right? We've seen them. We live in Abbotsford. There's farms around. They have silos. That's what it looks like. So the surface area is what? What is this part of it? Cylinder. What is this part of it? Hemisphere. So the surface area of this is the surface area of a cylinder plus the surface area of a hemisphere. Now I got to think. Where will paint go? Where? On the outside. That'll get painted. And that'll get painted, correct? Right? Will this circle on the ground get painted? No. Will this circle in the middle up here get painted? Yes or no? No, because it's empty space. So what I have now is the surface area of a cylinder, which is 2 pi r squared plus 2 pi r h. But, am I painting the circles? I'm only painting the sides. So it's 2 pi r h. In the hemisphere, that's 4 pi r squared divided by 2, right? And you're supposed to add in the circle. But are we painting the circle? No. So I'm not adding that circle in. What's 4 divided by 2? 2 pi r squared. Oh, look. Now, all you got to do is fill it in. And the question said the height was something like 20. I can't remember. Who cares? This is 10 meters, and this is 4 meters. Then all you do is fill it in. 2 pi, what's the r? 4. What's the height? 10. That covers the cylinder. Plus 2 pi, what's the r? 4 squared. 40 times 2 is 80 pi. 16 times 2 is 32 pi. 80 plus 32 is 112 pi. Everybody get it? Do not, in any of these questions, did I go straight to a formula, even once? No. What did I do first? I decided what I needed from that formula. Because in the real world, you don't usually see a cylinder, do you? You see cylinders used, like making the silo here. In math, it's a cylinder. But in the real world, it's missing the bottom and it's missing the ceiling. So it's not a cylinder, is it? It's just the sides of the cylinder. Is everybody good? All right. Wow, that was 10 minutes. So, I have your quiz right here. It is, I lied. This one isn't multiple choice. This one is all open-ended. But it's easy. What are you going to write on it when I put it on your desk? Your name. Excellent. Then you're going to do the work. How much work are you going to show me? As much as you possibly can. Is it legitimate? Is this a realistic thing for you to do? Look at a question and leave it blank. Is that realistic? No, why not? Everything on here is a shape, isn't it? Every shape on here has a formula, doesn't it? So at the very least, could you not fill in the formulas? At the very least, should you not be able to get half marks on here? Yeah. What will you get if you leave it blank? Nothing. Picking up what I'm putting down? Read my mail, mowing my lawn? All right. Well, I started at the front last time. Take one. No, wait. Sophia. Take one, pass it forward. Take one, pass them forward. Then the back can start first. Then I'll keep it even for you. Why? Because I care. That's a naughty looking side. From back here. But it's already recorded on YouTube, so it's too late. It's on there forever. I'm just going to leave it.